Well, good morning. Well, first, thanks for coming. And who was in a party last night?
Party, yeah.
Party, right? Well, thank you for coming. I know it's hard. Yeah. Well, welcome to this session. This is the first time I'm doing EDV360. So what you see here is the first time I'm presenting this tool, which is nice. Okay, so first a few words about myself. I mean, that is me. Life is good, that's what I say, that's how I feel. It has to do a lot with the optimism and the way we see life. Very quickly, I do performance, I do SQL tuning. When people ask me, are you a developer, are you a consultant, a DBA, I would say pretty much all of the above. I mean, I consider myself, the three of them. I am the author of EDV360 and eAdam. And before those two, I was also the author of SQLT and SQL Health Check. Now, SQLT is being maintained by Mauro Pagano, that is here. So you may want to know him. And I also do Exadata. A quick history, I started working for Ford a long time ago. Then I moved to Unisys, which was Xerox in those days. I did a lot of development on mainframe. Then I moved to Oracle, and I stayed in Oracle like 17 years. And after that, I moved to Enkitech, which is now part of Accenture. So that's pretty much, who I am. So what is this EDV360? Some of you guys have already used this tool, right? Who has used this tool before? A couple of hands, 3 hands, okay. Maybe? Okay, so maybe you want to comment. No, I think so. Okay, so EDV360 is basically a tool that we have that provides a 360-degree view of a database. It's made of SQL statements, so you look at the content, it's just a bunch of SQL statements, SQL scripts. One thing that we have here, it installs nothing on the database, which is very important. In these days, you want to execute a tool, and the first question is, does it change anything on my database? The answer is no. Another one that is important, it executes from SQL Plus. It could be local or remote connection, doesn't matter. So that means if I have no access to the database server, but I have a client connection, I can connect to a SQL Plus, fine, I can execute the tool, okay? Which is also important, because in these days it's quite common that we don't get access to the database server. The output is a zip file that contains many files. That's pretty much what it is. How do we use it? Why do we want to use this? The first one, I would say, database health checks. What is a database health check? It's like you are thinking your database is fine, or maybe it's not quite fine, and you want like a third-party review of your database to take a look at everything, right? So basically, this person can give you an unbiased situation in your database, but you don't want to give this person any access. So that becomes a challenge. How can you make some diagnostics without having any access to the database? So we use it for offline performance analysis. That is another way to use it. Another way to use it is sizing. You are considering database consolidation, capacity planning, and you want to understand the environment, the database, and the resources, you use EDV360. Typical use. I am a consultant, I go on site for 1 week, and when we say 1 week, it's usually from Monday, like midday until Friday morning, maybe, it's like 4 days. And when you get on site, it turns out that you have no access whatsoever. And not even internet access in some cases. So you are here for 1 week to tell me what is wrong with my system, but by the way, you have no access, okay? And it's quite common that you meet the DBA, say, yeah, you give me everything you need to run, and you give the DBA a script, and 4 hours later, you have the output, right? And you have like only 4 days. So in cases like that, you want to use something like EDV360. Another use is when you have a client, or you are the client, and you are considering something like engineered systems, and you have multiple databases that you want to consider for the migration or consolidation, and you need to evaluate resources. So in that case, many databases into one database, how do I do that? How do I see those resources? Overlaps with other tools, yes, there are some overlaps. Of course, the first one is DBA's scripts. Every DBA has a bunch of scripts. And who is a DBA here? Oh, pretty much everyone is a DBA. So you know you have a bunch of splits, right? So we have some overlaps. We also have some overlaps with OEM. I mean, once you see EDV360, you say, yeah, I can do the same with OEM. Just keep in mind that with EDV360, you don't have to have a persistent connection to the database. It's one time, and everything is offline. So we have some overlaps with AWR and ADDM. The way I describe EDV360, it complements other tools. If you already have a lot of tools, that's fine. Just use your tools, and you may want to consider using EDV360 as an addition. How do we use it? How do we execute EDV360? It comes with a very short README. I mean, no one likes to read a huge file just to understand how to run a tool, right? So this file is very short. It tells you how to do it, which basically is going to say connect to the database through a SQL Plus connection. It doesn't matter if it is local or remote. And if you have SYS, connect as SYS. If not, if you have DBA, connect as DBA. If not, if you have just a standard account, as long as you can access the data dictionary, you're fine, okay? Parameters, 2 parameters. The first one is going to ask if your site has a license for tuning or diagnostics pack. If you say no, you still get some output, but very limited. So if you do have a license, go ahead and say tuning if you have the tuning pack, or D if you have diagnostics pack. So you get all the information. And the second parameter is how many days of history do you want. By default, we have 31. And it will depend on the retention time that we have on AWR. So if we have a retention of, let's say, 1 year, then you can say here, 1 year of data, right? But if you only have a retention of 7 days, then it doesn't matter if you say 31 or 7, you get the same. Is that clear? Very easy, only 2 parameters. In terms of output, what do I get? As I mentioned before, we get only one file, one zip file. So we run EDV360. It reads some metadata from the database and produces a zip file. That's all I need. So for example, if I am remote and I am asked to do an evaluation of a database, I say, you know what, run EDV360, give me the output. That's all I have to ask, and the only thing that I get is this file. Then I can review all your environment with only one file, right? When I open that file, this file contains hundreds, I would say close to 1,000 or maybe more than 1,000 files. And I always look for number 1 here that says index. That is the one that I want to see. So let's talk about the content. What did I get? What is the content? Well, just think this way. EDV360, it has a lot of queries on top of the DBA static views. So basically I can see configuration of your database. And we also have some queries on top of GB dollar views, which basically we can see performance. Okay, so we have those 2. It also has some AWRs, some ADDMs, and some ASH reports. It's going to select which ones we care about. And a sample of SQL statements. I mean, as you know, if you are doing performance for a database, it's quite common that at the end, you will need some SQL tuning. So basically, it's going to give you a heads up on those SQLs that require some attention. The output looks like this. Can we read from the back on? No, I wouldn't expect to be able to read. So this is the output. As you notice, the output can be kind of overwhelming. Usually the comment that I get is, oh, it's overwhelming. Yes, it is. There is a lot of information behind, lots. So keep in mind that basically what we have is a 360-degree. Now, if we start clicking those links, the first thing that we will notice is that we have like 4 formats. We have for a given output, we would see text. Everyone likes text, right? Well, some we prefer HTML. I don't know why, but I think reading HTML is easier. In some cases, we rather have the data as a CSV. Why? Because we want to do some data mining with this data, right? Maybe a sort, maybe just an extraction. We want to do something with this data. And in some cases, we can visualize the data better with a chart. Well, with EDV360, we get the 4 of them. I mean, for every query, if we can produce the 4 results, we give you the 4 results. Okay, why? It's just a matter of taste. I mean, some people can visualize the data better with a chart. Some people can visualize the data with just the values, right? So we have them all. For each report, we get who is the source. I mean, where is that we're getting this data from? Some of the concerns or some of the issues I have with AWR at the beginning is like, you see some data and you say, where is this piece of data coming from? I would like to know what is the object, what is the DBA object that is behind. Well, we get that here. We get the source, and we get the output in those 4 formats. We get the description of the object. So if I am doing a select from this DBA view, I want to see all the columns on this view, and we get the SQL statement. For example, here, this is a typical output. So we get the source saying, okay, this SQL is coming from this view. This is the output. This is a describe of the view. And finally, and very important, is the SQL. In many cases, you see these tools or this output that you say, oh, it looks fantastic. I would like to understand where is this data coming from. Well, sometimes it's not that trivial to see what is the SQL that is behind. And sometimes it's better if we know the SQL. So we can say, you know what, this is wrong. Or you know what, now I understand why this value is here. So EDB360 has 7 dynamic columns. So that means if I run EDB360 in one database and I run it on a different database, the content of this report changes. Why? Because since it's assuming that you don't have the opportunity to go back and forth several times against the database, it has to do some analysis in order to present what is important. For example, if I'm going to show you weight events, well, I mean, we have thousands of weight events. I cannot treat all those weight events like equal, right? I need to give special treatment to those weight events that are causing some pain. Is that clear? So some of the SQL that we see here, it depends on where is the pain. I mean, where is that you're spending more time. So I say, I mean, we have 7 dynamic columns. I was trying to find a picture of dynamic columns, and that is all I found. Okay, so I wouldn't say these columns are dynamic, but the ones that are missing, those were dynamic. Okay. So let's talk about the first column on the report. On the report, the first column is going to include those 5 areas: configuration, security, memory, resources. Resources are mostly coming from AWR, and then we have resources coming from a stats pack. So if I want to see those pieces, they are there. So now let's just zoom in so we can actually read them. Can we read that?
Yes.
Yeah. So that is just to give you an idea. Then I you notice, I mean, we have like hundreds of links. I cannot just go ahead and click on every link and show you the output, but we will stay here the whole day. Okay. So this is a piece of the first column. This is the second piece of the first column. So we have information about configuration, security. If I look at one entry, for example, let's say I click on this SGA and I click on the HTML part, I will get something like this. As I mentioned before, we have what is the source, what is the output of the SQL, what is a describe of the view, and then what is the SQL. So if we don't like the SQL or we want to validate the SQL, you can take the SQL and run standalone. Okay? If we talk about resources, we focus in 5 pieces. We focus on CPU, memory, disk in terms of space, and then IOPS and MVPs. When we're thinking resizing or we're thinking capacity planning, normally those are the 5 that we care more. So we have those in there, and you will notice some patterns. I mean, we have CPU first, and then we have memory, we have a database space, then we have IOPS and MVPs. This second part for the stats pack is work in progress. Why? Because not every customer has AWR. So if we don't have AWR or we have a stats pack, that part, the one that says a stats pack, is going to grow. Not as big as this one here, but it's going to be bigger in a few releases. What about clusters and instances? How many here are working with RAC? RAC, pretty common, right? So for RAC, sometimes we want to see the data from the cluster perspective, and sometimes we're gonna see all these metrics from the instance perspective. So with EDB360, we get both. I mean, you will see many of these entries. They will say, oh, these are the numbers for the cluster, so that means that is for the entire system, for the entire rack system. And then we have the details per instance, so we can focus on particular instances. So for example, if I show you this chart, I will notice that it says cluster. So this one is CPU demand, and it's a time series, and it's going to show me the peaks of every hour. And it's coming from ash. This is pretty much what I read on the first line. So I know this one is coming from the entire cluster. I know that the average number of CPUs on this system is 4. I already knew we have 4 instances. So if I want to, let's say, do like a quick analysis, I notice that this peak, it doesn't reach the number of CPUs on the cluster. That's fine, that's something quick that we can analyze. We also notice down here, we have a resource manager, a CPU quantum. So that means we have some queuing on the CPU. Okay, we notice that, that's fine. When we look at the same report for one instance, we may notice that we may have some spikes like this one here that exceeds the number of CPUs on that host. So that may look like a little bit of trouble. So we can do this kind of analysis, I mean, going from the cluster to an instance. And that's not all we can do. We can do a lot more. Why we can do a lot more? Well, EDB360 is using Google Charts. Who is using Google Charts here? Google Charts, 1 person, 2, 3, 4. They're becoming more popular these days. Google Charts allow you to do this. You can zoom. You can zoom. And remember, the data is inside your report and is not coming from the database on a persistent connection. So you took a snapshot and then you basically navigate your data on your report, right? So that is very important. So Google Chart is pretty cool. I mean, we have this zoom functionality that I really like. For example, this one here, I mean, I'm doing a zoom, so I can review those peaks in more detail. If I want to zoom even more, I can do that. So that's something that we do. Another example of all these reports, this one is IOPS. And what do we observe here? When you see the data on a chart, it's very easy to identify kind of areas of concern. So in this case, the thing that comes immediately is something happened here. I mean, we don't know exactly what happened, but we know when it happened. And we know what that is affecting. In this case, it's affecting read IOPS. So we have an intensive period of many reads. Let's move to the second column. The second column, we have information that is relevant for DBAs. We have storage information and ASM. Those are the entries that we have. And if we look into more detail, for database administration, we have all those pieces. So just go ahead and read through it so you can see what it is that you get that is usually interesting for a DBA. This is the second part, because the column was too long. If I were to mention just a couple of them, I may mention this, I may mention constraints, for example. I may mention redo log information. What about constraints? And we're just zooming into one of the reports. What about these constraints? Well, these are disabled constraints. And what kind of constraints are we having here? Foreign key. So what is going to happen if I disable foreign key constraints? What happens? I am risking application data corruption. It's a risk. I'm not saying it's going to happen, but we're risking that. So by getting this report, I say, you know what? We have way too many constraints that are disabled. If this is a production environment, I will be extremely concerned. If this is dev or QA, I will be still concerned, but maybe not as bad as it is production, right? So what is this one here? It says non-index foreign key constraint. This is a different one. This one is saying you have constraints, they are enabled, but you don't have an index to support them. So what may be a consequence? I mean, if we have this situation, what may happen? locks and latches. Yes, it's a risk. I'm not saying it's happening, but as a DBA, I'd rather know this beforehand, okay, and not in the middle of the night. So I'd rather take an action here instead of just waiting for this to explode. And that's just to give you some examples. Then we have information about the storage, ASM, and another one of the reports I just chose kind of random is this one here. The largest 200 objects. I know it's a little bit hard to read, but basically what I want to highlight here is in this particular case, 8 tables, they consume 80% of the database in terms of size. So I may want to do something about those tables. Or we can say, with these 20 tables, we're consuming 90% of the size of the database. If I am a DBA, those would be areas of concern. Saying, can I do something? Can I do something with this table? Do you still need this table? Maybe that was a temporary staging table that I can drop, right? Another one is this report that shows segment strength recommendations. And if I just look at the first one, it's gonna say something like, if you were to compress this table, you will be saving this much space. As a DBA, I like saving space. And those are just a couple of samples. Now, column number 3 is going to talk about resource manager, plan stability, the CBO, some performance summaries, and some OS statistic history. So it looks like this. Let's take a quick look at some of these entries. We have resource manager, we have plan stability. For plan stability, for example, it talks about profiles, a SQL plan baseline. What is that we have? Why? Because if I don't know your system and I am a DBA that just getting acquainted with your system, I need to know what's going on. I need to know you have, let's say, 3,000 baselines. I want to know that, okay? So those are the questions I'm trying to answer. And what about the CBO? The CBO is like a huge animal. I mean, we have a CBO system statistics, table statistics, index statistics. I cannot give you everything, but I can give you some pieces that are important. For example, I'm going to talk a little bit about system statistics, and then something about those global temporary tables and you'll say locking statistics. If I show you these, what do you notice? What can you tell me if I show you this? These are the CBO system statistics. Workload, no statistics. What do you see? You don't have system statistics here. In this system, you don't have system statistics, which in general is fine, totally fine. I am kind of unbiased about collecting or not collecting system statistics. There are some pros, there are some cons. In this case, I see this one, and the only thing I can say is we don't have system statistics, and that's fine. What can you tell me from this one here? This is from another database. What do you see? The workload, but not only that, there's some workload, yes, but more important, what can you tell me? I know Mauro knows, but anyone else? That single read time, that number is huge. That is totally abnormal. That is above, okay? So I can see we have above here. So single read time is a huge number. Multi-block read time has no value. So this is inconsistent, the quality is not good. If I, which row? I'm looking at this one here. That value is like 1,000 times bigger than what is normal. Okay? So there is a bug, it's documented. So I know this one has this bug. And more important, this one is inconsistent. I'm giving a huge number for single read times and no value for multi-block read time. Most probably, the CBO will be okay, because with this inconsistency, the CBO will ignore both, okay? But it's a red flag. It's saying the quality of your CBO statistics is not good. That's what I see. What can you tell me of this one here? That's another example. Exadata. This one, it seems to be that it's an exadata, and when we collect the CBO system stacks, we pass the parameter exadata. Why? Because the signature of that parameter is this value, this column gets a high value, usually in this order, 128. So it's fine, nothing wrong. So when I say that we use EDB360 for health checks, it doesn't mean EDB360 is going to do the health check for you. It's going to give you whatever you need for you to do the health check. Is that clear? It's the same as SQLT. SQLT explained is for SQL tuning, but it doesn't mean you use SQLT and it's going to do your tuning. No, it's going to give you whatever you need in order for you to do your homework. So here we have some other examples. We have some logged statistics, some tables with logged statistics could be just fine, but it's possible that you say, you know what, are we saying that we log statistics in the year 2007 and we only have one row? It looks suspicious, okay? Because that means if the row is not changing at all, maybe your application is using constants instead of using this data. And if you're using this data for something, most probably in the past 8 years, the data has changed. Is that clear? So those are little details that you say, you know what, it doesn't seem right. It's suspicious. Now, if it happens that when you're looking at the SQL and the SQL is performing poorly and it makes a reference to this table, then it becomes more suspicious. Does it make any sense? So it gives you some clues from different parts of the database. In this one, global temporary tables, and they have statistics. In terms of better practices, or I would say good practices, when we're using global temporary tables, more common than not, we don't have statistics and we log the global temporary table. So we use dynamic sampling, right? I don't see that here, so that may be a concern, especially when you notice those statistics are old. That's another red flag. Temporary tables, when someone creates a table that is not a global temporary table, but the name of the table includes the keyword temp, what is that telling you? The intention was to put the staging data. As a developer, that is like, you wanted to put staging data. Then if that is the case, why do you have all these outdated statistics, right? So those are little things that you start like EDB360 is telling you the story. So it's just a matter of listening the story, because the story is there on EDB360. Some performance summaries, some OS statistics. When we say OS statistics, we don't go directly to the OS, but the database provides a view that basically contains the OS statistics, and that's what we see here. For example, we can see CPU time percent for a cluster, or we can see CPU I/O weights per instance. Those are the kind of things that we can see. Let me just show you some of these charts. If I show you this, it says CPU time percent for cluster. What can you tell me about this system? Is it busy? Is it idle? Time as a percent of the number of CPUs. Okay, so this is percent. And this one is telling you this blue means idle. So idle is in the order of 90%, busy is in the order of 10%. I would say this one looks like pretty much an idle system. Okay, that's what I see. That's what I see from this chart. Some of these charts, since it's the first time you are seeing them, it takes more time for your brain to analyze the chart and then analyze the data. But once you get used to them, it comes immediate. I mean, what is the meaning of this chart? What do you see on this one? This is, for instance, 4. What do you notice? Something happened here, right? It became busy, really busy. It was a spike. And then it remained busy for quite some time, and then it came back to normal. That's what I see. There was some load, and something happened here. What was that event? I don't know, but something happened there. What about this one here? What do you see here? In this one, we can see the 4 instances, and what you see here is the busy time. What about balance? Are those instances well balanced or not? Yes, no? Well, it all depends how you want to see this, right? Because if you were to magnify some pieces, you will know that they are not well balanced. But maybe what it's telling you is that these instances are specialized. So you have this instance maybe for this application, this other instance is specialized on this other application. That's the way I would see this one. It seems to be that there's some sort of a specialized instances here. What about this one here? This is load for cluster. On load, I would expect to see line going up and down a little bit, but what do you see here? Do you see some trends? Load was growing. This line here is the total number of CPUs that I have on my system, and load was bigger than that, right? And then something happened here, and load came back to normal. Okay, that's what I see. Okay, let's move to column number 4. What do we have on column number 4? We have information about memory, SGA, PGA. We have statistics about memory, a system time model. That's another important component. Then we have the I/O weights and some histograms for the I/O weights. If we were to see more detail, we notice, we have some charts for SGA, PGA, also for memory, for system time model. I'm going to show you a few of them, and then we can see the different components. This one is the consolidated view of the system time model according to the different components of the system time model. So what do we notice here? The colors, I see the colors very nice here, but I don't see the colors very nice here, okay? So the colors, believe me, they're different. These two are different, they're not the same color. So from the chart, I can see database time, and I can see that the major component of that database time, it was what? SQL execution. So there was a spike. So that means there was some runaway SQL, there was something that happened here that totally exceeded my capacity. Okay, I see that, there was a spike, that would be a concern. Another thing that I noticed is in average, the active sessions is 50, which it seems to be large. In general, you see active sessions 5, 10, 20. When you see 50, it's like, this seems to be like a big system, quite busy system. That's what I see. What about I/O weights? Let me just give you some samples here of I/O weights and how they look. When we're looking at I/O weights, we care about latency. We're saying, okay, my I/O weights are less than 1 millisecond, maybe they are less than 30 milliseconds. I want to understand how they go. So this is a sample, and if I put the mouse over, I can see pretty much, like in this particular case, 70% of the I/Os, they take less than 2 milliseconds. Pretty good. I like it. Fine, no issues at all. But if I show you this, what do you see? Some performance degradation in your I/O, right? It happened here, and it happened here. What is that it happened? Which process was running? I don't know yet, but I know something happened. Is that clear? Does it make sense? So I can see. So there was something that happened there, and there was something that also happened here. And then if I zoom, I can get the details, and I can see better. For example, in this case, I can see something like this. Most of my entries are in this range, so they were taking a lot longer. Okay? Where is this data coming from? It's coming from here. This one here. Column number 5, the focus is ASH. So we get a lot of information from active session history. And as you know, active session history is a beauty because you can summarize, you can aggregate in multiple dimensions. And if you want to do that manually, and you have the tools, that's fine. Here's another way to do it, through EDB360. So we get ASH first, we get ASH per weight class, and then we start looking at some top weight events. This list of the top weight events is one of the lists I say at the beginning that is dynamic. Well, the content here depends what is important. that means whatever is taking the longest time. For example, here, one of the particular wait events that we notice is this one, NQTX. And it's going to give you what is the source of that NQTX. So in this particular case, we can see there are like 3 SQL statements that are causing most of these logs. Okay? What can you tell me from this one? What do you see here? This is average active sessions waiting on user I/O, and in particular the DB5 sequential read. Well, when I see this one, I see some spikes, I see some peaks. Fine. I see some patterns. It happens daily. And more important, it's growing over time. And at some point, the performance collapsed. Can you see that here? From this spike over here, it couldn't recover as fast. So it wasn't even recovered when we reached the next spike. That's what I see. So something happened there. The pattern that we see, it seems to be that it was like weekends. If we look, no, it's daily. We can see 27, 28, 29.
It's like 5 birthdays and 2 weekends. Both have 5 birthdays.
Yeah, ETL on weekends only, and the last 2 are the weekend.
It's possible, yeah. I mean, if those days are weekend, that may well explain what's happening. Yeah, yeah. Just keep in mind, EDB360 allows you to do this kind of analysis. You can say, you know what? I noticed something else is going on the weekends, okay? And maybe nobody complains because nobody's there. So we have on this column, number 6, we have ASH from different perspectives, different dimensions. We can see top time events, we can see top SQL, top programs, modules, users, and PL SQL. And for each one of these, we have a lot of entries, a lot of different views. I mean, we can see for cluster, we can see per instance, and they look something like this. In this case, we're looking at ASH, the top wait events, and it's looking for the past 31 days for the cluster. And which one is the one that is taking the longest in this case? We can see is streams. So if I were looking at my ASH for the past 1 month, this database, most of the waits are coming from the streams. Why? I don't know. I just tell you some facts, okay? If I were to look at the past 1 hour for the same system, it's not the streams, it's something else. So we have some CPU, and so we have some user I/O direct path. So that means the load is not persistent over time. The load is changing. Whatever we're doing with this system is changing over time. If I were to look by SQL, I can see which SQLs may be causing some pain on the past hour, on the past 4 hours, on the past 1 day, on the past 7 days. So you have different views of the same data over time and through different dimensions. So I get a better idea of what's going on with the system. Keep in mind, all this is because I do not have access to Enterprise Manager. So I need to find a method to get a good idea of what's going on with the system in one shot. One SQL, tell me everything about the performance of this database over time through multiple dimensions. Okay, that's pretty much what we're doing here. So we can see top programs, top modules, top users, top PL SQL procedures. Column 7, that is the last column. In column 7, we include AWR, ADDM, ASH, and some SQL statements. Okay. Now the question is, what is that we get? I mean, if I go to a site for the first time and I ask DBA, just give me some AWRs. Well, chances are that I will get the AWRs I care about, but chances are I won't. So what is doing in EDB360 is going to give you a sample of AWRs, but the focus is those moments in which the system was busy. So if I drill in, the portion that says AWR looks like this. ADDM is very similar, it's for the same time periods, and ASH is for the same time periods. Now, how do we determine the time periods? Well, we look at the DB time, and we look also at the background elapsed time, both of them, and for every instance, we look when the system was the busiest, for the past 7 days, for the past 5 working days from 8 to 7, for the past 24 hours, and for the past 4 hours. So we look at the 4 of them. So instead of giving you 1 AWR, I give you 4 AWR per instance. So it's possible that for this instance, the worst time last week, it was on Friday. But for this other instance, it was maybe on Thursday at noon. So I give you those 2 AWR reports. And then on top of that, for each one, I give you the corresponding global report. So you want to see what happened for this instance when it was the worst for this instance, and what happened when it was the worst for this instance. But at the same time, for both, I want to see the global. So I want to see what else was going on the system. Okay? So that's what you see on reports. You will see, for instance 1, you may find several reports. For instance 2, you may find several reports, and that's fine. How many? Well, it could be many reports. Let's say, for example, this is a 4-node rack. We have, of course, we have the 4 instances, right? And we have 4 time intervals per instance. So that means we have peak, 7 days, 5 days, 24 hours, 4 hours. And for each one, we have 1 global report and 1 instance report. And we have 3 reports. We have AWR, ADDM, and ASH. So in this case, we're talking 96 reports. It sounds like a lot, and maybe it is a lot. In some cases, I'd rather have I'd rather have more than less. Okay, so I get all the reports, create these links on the main page so I can see all of them, and then I can click on any one of them and I get the actual report. SQL sample. When I think SQL, this is what comes to my mind. Complexity. SQLs are usually complex, right? So in this case, it's going to give me a list like this one here. So we have 16 SQL statements, and the amount of output for each one is different. For some, I have a lot of links, and for some, I only have 1 link. So what's going on? What is that we're doing here? So what we're doing, we're going to be looking at the top SQL according to ASH. Why? Because ASH basically includes everything. It basically is going to tell you the last time. It's going to say, oh, if this SQL is consuming a lot of CPUs, well, it's going to be on ASH. If it has many weights, it's going to be on ASH. So you look at ASH as the number of samples that you have per SQL for different time intervals. Like let's say for the past 1 hour, or the past 4 hours, or the past 24 hours, or the past 5 days, or the past 7 days. If you do it at the same criteria for each time period, you end up with 5 lists of 16 SQL statements each list, the top 16 of each. And then just take the most popular 16 SQL statements from all these lists. And this is how we get the list. Does it mean this is absolutely 100% accurate that it's going to be the top SQL? No, not really. But it's basically the SQL of interest. Okay? With that sample, I know what's going on with your system. So for the top 16, I get this Plan X, which is a small tool. For the top 12, SQL Monitor. For the top 8, SQL Ash. And for the top 4, SQL Health Check. If you put the SQL Health Check on the same directory. SQL Health Check is something that you can download from my Oracle support. It's also free, but you have to download. Put it on the same directory, and then you also get SQL Health Check. So this looks like a pyramid. All these pieces are going to be enhanced with this new tool that is called SQL D360. It doesn't exist, but it will. Okay? So some closing remarks here before we run out of time. Typical question I get is, how long does it take to run EDB360? Well, it takes some time. So I prepare my customer and say, you know what, it's going to take between 1 hour and 3 hours. Most probably, it will finish in less than half an hour. But I'd rather set the expectation that it's going to take a few hours to run. Okay? So I will say, you know what, running at the end of the day, when you're ready to go home, just put it to run and go home. EDB360 gives you a fair view of the database. It doesn't tell you everything, but it tells you enough. Enough to start working on your case, whatever is your case. If, let's say, on this host, you have 20 databases, you don't want to do it manually, one per one, doing EDB360. There is a shell script that is provided that runs EDB360 in all 20 databases. So, and it produces 20 files, one for each. Okay? So it's very easy. Just put it to run. Next day, you have all your EDV360s. There is like a new release every once per month. It's like my weekends project when I have nothing else to do. I don't watch TV, so I use my TV time to develop these tools. And this is very important. This one installs nothing and it is free. Okay, no strings attached. That's something you download, you use it. You don't like it, well, you get what you pay for, right? No, there is no harm. If you don't like it, don't use it. Beyond EDV360, what else do we have? Well, we have this eAdam. eAdam is like the brother, I would say, the brother of EDV360. eAdam is an AWR data mining tool. Okay, so this eAdam basically takes AWR from this system, puts all the data in this other system, which is a stage system of my PC or my laptop, and I do all the data mining here without affecting the source database. Okay, so I don't put any pressure there. I just extract data, create a flat file, and then put my data here, and I do all kinds of analysis. That's what we have, and it's available. It's free. ESP is another one that is proprietary. That one, if you want to see it, you can stop at Accenture booth. At Accenture booth, you can see how it works. It's for sizing. That one, unfortunately, we cannot offer this for free. I mean, we don't sell it. It's just proprietary, but it's cool because that's what we use for sizing. SQL D360 is work in progress, and it will be available. Once it's available, it will be embedded inside EDV360, but we will be able to use it standalone. Okay. It's not the idea to replace SQLT, so don't look at me like that. Now, SQLT is still out there, but this one, the main difference is this one installs nothing on the database. Okay. Some references. You want to download the tool, it's available there. You want to see the capabilities, it's there. You want to download eAdam, it's also there. You're waiting for some pictures to be taken. Go ahead.
So you are saying this tool is more like look at this whole picture. Is this tool can be used to diagnose what's currently happening, what is currently happening?
And the question is, can we use this tool to determine what is currently happening? Kind of yes and no, because when you take a snapshot of the entire database, you're looking at history, but you're looking also at the current situation, right? So you have everything in front of you. Now, does it provide like a monitoring that you can refresh every 5 minutes or so? No, it doesn't. So it gives you everything from the past up to this time, up to this moment. Configuration is whatever you have right now, but history is whatever you have from whatever retention period up to today.
Have you looked at the AWR warehouse product, how it compares to eAdam?
Have I compared eAdam with AWR warehouse?
Yes.
No, I haven't. I haven't done that compare. I know AWR provides some utilities to offload and import back. And when I look at the functionality, it wasn't what I needed. It has some restrictions. For example, when you do an export of AWR, you are doing the import either on the same release or higher release, or you cannot go lower. In this case, I can go lower, it doesn't matter. I can get an eAdam snapshot from 10G, from 11G, from Windows, from Linux, it doesn't matter. I put everything into the same repository. There is no, I don't use export import, I use flat files and external tables. So, and I do remapping of the columns. So that means if I take, for example, eAdam that is coming from 12C and I do the import on 11G, it works perfectly fine. So it's a little different functionality. And then I can compare, I can do everything I want. I mean, on my repository, because I have all this data, I can consolidate, I can stitch data, which basically means appending data from, I took a snapshot of eAdam last week, I take another one today, I want to stitch them together, I can do that here with eAdam. So it has a lot of flexibility that I didn't see with the standard export-import of AWR.
I think AWR Warehouse, it's the consolidated view of multiple AWRs from multiple databases.
I will take a look at that. That's a good point. Thank you. Thank you. So, go ahead.
Current challenge in our environment is really about plan stability. Basically, usually it happens with like plan suddenly changes this morning, and it just
Yeah, so your concern is basically plan stability.
Yeah,
Like the
because
plan changes.
plan
Mauro,
change,
you want
if
to
it
say
change
something?
If it change for the better, I don't care. But if
But
it
it
change
change.
for much worse, then
You can.
I need to be warned instead of being told by the users. Okay,
That enhancement has already been requested. It will be here. That is going to tell you sequels where the plan changed and it became worse. That will be here. But Mauro, please go ahead and you want to. You're fine with that? Now, when you want to drill in and you have one SQL that has a situation, then you want to use SQL T. SQL T explain. SQL T explain. Just go to my Oracle support and look for node 215187.1.
Remember that.
I remember that number. I don't know how, but I remember that number. 215187.1. Okay, so that's my contact information. So I always one email away. So don't just shoot me an email. You have a question, just shoot me an email. Okay, I'm usually pretty good at responding quickly to my emails. Okay, so do we have any other questions? No question. Well, thanks for coming. Time for some coffee or coffee break.